Option map, flatten, and chain are essential operations when working with options in FPTS. To see why we need them, let's start by implementing a function called head, which given a generic array with elements of type A, returns the first element of that array as an option A. That is, sum A if the array has a first element and none if the array is empty. Here, we will simply check if A's is an empty array, and if so, we return none. Otherwise, we return sum with the first element of the array. So if we call head with an array that has 5, 6, and 7, we will get back sum 5. And if we call head with an empty array, we will get back none. Now, let's say that we want to define a getBestMovie function, which given an array of a user's favorite movie titles, sorted by rank, returns an option string with the title of the first movie transformed to uppercase and preceded by a best prefix. So if we call getBestMovie with an array that has two movie titles, An American in Rome and Winter Holidays, we want to get back sum best and American in Rome with the title An American in Rome uppercase. And if we call getBestMovie with an empty array, we want to get back none. Let's see how to implement this. So we should start by getting the first title, which we can do by piping the titles array into head and get back an option string. Then, if the option has a value, we want to uppercase it and then add the best prefix to it. In order to perform transformations on the option's value, like uppercasing it, we can use the option.mapUtil, which takes a function that maps the current option's value to a new value. Let's see some examples to get a sense on how option.map works. Let's say that we have sum 5 and we have a double function which doubles a number. When we pipe sum 5 into option.mapDouble, the first thing that map does is to check if the option has a value, which in this case it does. So map will pull the value 5 out of the option, pass it to the double function, get back a 10 from it, put that output into an option and return it. So we get back an option that wraps the value 10, that is sum 10. On the other hand, if we pipe none into option.mapDouble, once again, the first thing that map does is to check if the option has a value, which in this case it does not, since it's a none. So map will just return back the none without even calling double. So in summary, when you pipe an option into option.map, you are just mapping the value of the option, if present, to a new value. Returning back to the getBestMovie function, after we get the first title from the array, which is an option string, we can uppercase it using option.map, to which we pass a function that takes a string and returns it uppercase. And then we can add the best prefix to it by using option.map, to which we pass a function that takes a string and returns it with that prefix. So let's see what actually happens step by step when we call getBestMovie with two titles, An American in Rome and Winter Holidays. First, we pipe the titles array into head and get back sum An American in Rome. Then we map that title to uppercase and get back sum An American in Rome all uppercase. Finally, we map that uppercase title to one that has a best prefix and get back sum best An American in Rome, which is the final output that our function returns. Let's also see what happens when we call getBestMovie with an empty array. So we pipe the titles array into head and get back none. Then when we attempt to map that none to uppercase, we get back none since there's nothing to map. The same happens when we try to map that none by adding a prefix. So the final output is none. If we look again at the getBestMovie implementation, there are some ways to make it even clearer by extracting the two arrow functions that we defined inline into external functions. So we can define a custom toUppercase function, which takes a string and uppercases it. And we can also define a custom addPrefix function, which takes a prefix and returns a function that takes a string and adds that prefix to it. Then, in getBestMovie, we can replace the function passed to the first map with toUppercase, and the function passed to the second map with addPrefix best dash, which makes getBestMovie even easier to read. Notice how, when using option.map, we're always in front of the happy path since we just map the value that the option might have without having to worry whether the option is a sum or a none. Indeed, error handling happens behind the scenes since when we call option.map with a none, it simply returns back none and does nothing else. If we were to write the same example in an imperative style, we would have to deal explicitly with the error path, that is, the case in which the first title is undefined, either by throwing an error, as shown in this example, or returning null or undefined. Now, let's say that we want to write a function, inverseHead, that takes an array of numbers, ends, and returns the inverse of the first number. So we would just pipe the ends into head, getting back an option number, and then map that number into inverse. But wait, inverse would map the number into an option number, so we would end up with option number, that is, a nested option. So if we call inverseHead with an array that has 5, 6, and 7, we would first pipe that array into head, which returns some 5, and then map that 5 into inverse, which returns some 0.2. So we would end up with some 0.2, which is a nested option. If we call inverseHead with an empty array, we would pipe that empty array into head, which would return none, and then do map on none, which would return the none back since there's nothing to map. So we would end up with none. If, on the other hand, we call inverseHead with an array that has 0, 2, and 4, we would pipe that array into head, which returns some 0, and then map that 0 into inverse, which returns none. So we would end up with some none, which is again a nested option. Working with nested options is not ideal, so what we actually want is a way to flatten nested options. This is where the option.flatten util comes to the rescue, which simply flattens an option by returning the inner option. So if we pass sum3 to option.flatten, we get back sum3, since the inner option is sum3. If, on the other hand, we pass sumNone to flatten, we get back none, since the inner option is none. Finally, if we pass none to flatten, we just get back none. So, returning back to inverseHead, we can solve the issue with nested options by piping the nested option into flatten, and thus getting back a simple option number. Turns out that these two operations, mapping and then flattening, are so common that it's worth having a separate util that does just that. A natural name for this util would have been option.flatMap. However, in FPTS, this util is called option.chain, but you should just think of it as flatmap. Option.chain takes a function that maps the current option's value into another option and returns back the flattened option. Let's see some simple examples of using chain. Let's say that we have sum5 and we want to get its inverse. We can get it by piping sum5 into chain inverse. When we do so, the first thing that chain does is to check if the option has a value, which in this case it does. So chain will pull the value 5 out of the option, pass it to the inverse function, get back some 0.2, and put that output into an option to get some 0.2. Then, once the mapping is complete, it will flatten the option back to some 0.2 and return it. Now, that is the formal definition of what chain does, which is mapping and then flattening. However, in practice, chain will just return the option returned by the pass function without bothering to redundantly wrap it into an option and flattening it back. On the other hand, if we pipe some 0 into chain inverse, once again, the first thing that chain does is to check if the option has a value, which in this case it does. So chain will pull the value 0 out of the option, pass it to the inverse function, get back none and return that. Finally, if we pipe none into chain inverse, chain checks if the option has a value, which in this case it does not since it's a none, so chain will just return that same none without even calling inverse. So, in summary, when you pipe an option into chain, you are just flat mapping the value of the option, if present, to a new option. So, returning back to inverseHead, we can replace the map and flatten with a single chain.